So in this second video on differentiation, we're going to look at how to use the gradient function, the derivative, to solve problems. So quick reminder, we've got a function and we might want to know something about the y coordinate, in which case we need the function y equals. So if we know x and we want y, or we know y and we want x, we need the function y equals. But if we've got any question at all about gradient, about steepness, we need the derivative, the gradient function dy by dx. And then we can use that to either say what is x when dy by dx is something, or what is dy by dx when x is something. What's the gradient at a certain point? We've also seen how you differentiate, that you take the power, make it into a multiple, and then decrease it by 1. Take the power, make it into a multiple, decrease it by 1. Take the power, make it into a multiple, decrease it by 1. Take the power, make it into a multiple, decrease it by 1. So in this case, 3x squared minus 6x minus 18. Because x to the 1 is written x to the 0 is 1, 0 times anything is 0. So, that's all reminders. So we've got 4 types of question that we might encounter. And you can kind of think of it in this sort of grid way to help you to work out what you need to do. Now, if the question is anything to do with gradient, anything at all, the steepness, the gradient of the tangent, the gradient it's parallel to, anything to do with gradient, then you need dy by dx. You don't need your y function at all. You need the dy by dx. You're not even interested in y. Now, you might know what the steepness is. You might know that the gradient is 10, but you don't know what x is. In which case, you take your dy by dx equals, I don't know, I'll make it up, that, and you take your 10 and you substitute it in there, because you know what that is. And then you solve that equation, exactly. Or maybe we don't know what the gradient is, but we know that x is 10. In which case we take our gradient function, which I'll just make up, and the same thing, we substitute in what we know, but now what we know is x, so we substitute that in there, and then we would say that the gradient is 10 squared plus 3 lots of 10 minus 2. So in both cases, we're taking what we know and substituting it in. If we know x, we substitute in x. If we know the gradient, we substitute in the gradient. We might also have questions about height. So if it's anything to do with the y coordinate, then obviously we need the y function, not the dy by dx function. We might know that the y coordinate is 10, and we don't know what the x coordinate is. In which case we take our y function, I'll make it up, and we substitute in our 10 where it says y, because y is 10. So then we have this, and we need to solve that equation. Or maybe we don't know what the y coordinate is, but we do know that the x coordinate is 10, in which case we take our function and we simply substitute in x is 10. And then exactly the same thing, and we find out what y is. So the important thing is that if it's about gradient, we need the dy by dx function. If it's about height, we need the y function. Then we will know something, and we need to substitute that in. If we know x, fine, substitute x in. Fine, substitute x in. But equally, if we know dy by dx, substitute dy by dx in. Just replace dy by dx with 10. If we know y, then substitute that in. Replace y with what you know y is. So it's the same sort of process, but you have to think through which function do I need and what information can I substitute in, and then just solve from there. So let's have a go, see if we can do some.
Right, so we are looking for the y coordinates. We don't have to do any differentiation or anything like that. When x is 1, okay, so we don't know what y is, so we're trying to find out, but we do know what x is. So 2, 1 cubed minus 1 squared plus 2, 1 minus 1, which is 2 minus 1 plus 2 minus 1. That will cancel, so that's just 2.
2, yeah, exactly. Very good. Next one.
Okay, it's gradient now.
Yeah.
So I've got y, I need dy by dx. So take the power, bring it down, so we're going to get 2 times 3x, take 2x. 1 plus 2x to the 0 plus raw.
Yeah.
X lots of the what's
Yeah.
it. So that's 6x squared minus 2x plus 2.
Yeah.
Then, so that's the gradient of the tangent of that curve
At that point. Yeah.
when
at
x
some
equals
point.
1.
Yeah.
So we don't know what the gradient is, we don't know what this dy by dx is, what we want to find.
Mhm.
But we do know that x is 1.
Yeah.
So dy by dx is 6 lots of 1 minus 2 lots of 1 plus 2 minus 2 plus 2 cancel each other out, so you get 6. So the gradient of that, the tangent to that line at point x1 is 6.
Yeah, yeah, the steepness of the curve at the exact point x is 1 is 6. It's going uphill, quite steep. Yeah?
The point P on the curve and has more.
Yeah.
The point P on the curve has a y coordinate minus 1. What might the x coordinate be? Okay, so we know that this equation, y equals 2x, la 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 la, has a y coordinate minus 1. Minus 1 sits on
Yeah,
that,
y
right?
is minus 1. So you can substitute in y is minus 1, yeah. And then you think, have a
Which
look at
I
that
found.
and see if you can...
I can take the minus 1 off each end,
Yeah.
so that's 2x. So minus 2x.
Yeah.
Factorise out an x, 2x squared minus x plus 2. Sorry.
So that's one possible solution, isn't it?
Yep, or 2x squared minus x plus 2 is
Yeah.
0.
Does that factorise?
No.
I don't think it does, no.
First formula?
Yeah, normally I like to use completing the square, but that 2 there,
no.
that, nah. So I would probably use the formula, to be honest.
So minus b, 1 plus or minus the root of...
Can we write x equals this? Yeah.
1 minus 4
A, C, yep, all over 2a. A is 2. What happens? What happens when we try and solve it? Oh yeah, A. You know what A is. A is 2.
Yeah, so we've got x equals 1 plus or minus the root of 1 minus 2 or 16 all over 4. That's a negative root.
Yeah, that's square root of minus 15. Can we do that?
Not right now, we can't.
No. I mean, if we could solve that, it would be 1 plus or minus the square root of minus 15 all over 4, but you can't, unless you do further maths and learn how to do it, you can't square root a negative number. So the fact that we've got a negative number inside this square root means that basically we've come to a grinding halt. So there's nothing we can do. So we were unable to solve this part of it.
Yeah.
So this part of the equation has actually no solutions. And so we only get one answer.
So is this like saying, say this is our graph, we're looking at where y is 1, aren't we? We're looking at this
Minus 1 we were looking at. Yeah,
that one there.
yeah.
It's like saying that the graph does that, but then kind of does that.
Yeah, exactly.
So we know that solution is actually 0, isn't
Yeah,
it? It's
yeah.
there. But that actually, where we would expect to perhaps find 2 more places that it cuts to
Yeah.
minus 1, it doesn't.
No, there is literally only one value of x for which the y coordinate is minus 1. Yeah, exactly. Okay, 2 to go. Right, how are you going to solve this?
At what points on the graph is the tangent, gradient of tangent equal to 1? So that we're talking about the gradient being equal to 1.
Yeah, so that's the important word.
Yeah, so this we know, right? dy by dx equals 1. Something we might use later.
Yeah.
So let's work out what dy by dx is in terms of algebra. So 6, this is the same one, isn't it?
Yeah, that's it. And then the point is exactly what you wrote here. The gradient, we're not told x, we're being asked for x.
The
But
gradient.
we know that this thing here equals 1. So we can just substitute in 1. That's it, yeah. The gradient's 1, so we end up with 1, and then you've got to solve this equation.
so I'm taking 1 off both sides.
Yeah. Do you know what? I think, I might be wrong, but I think this doesn't work very nicely. So shall we change it? I think if we change this, sorry about this, to a 6, I think that equation is disgusting.
That looks really hard.
It looks disgusting, doesn't
Yeah,
it?
it doesn't look
Okay,
so
so I'm going to pretend that I said where is the gradient equal to 6. So the gradient's actually 6. So what we're subbing in is a 6.
And that's a 6.
And that's a 6.
That's a 4.
And that's a minus 4.
Minus 4.
I think that's going to be nicer because look, everything divides by,
By 2.
Sorry about that.
That's alright, so it's 3x squared minus x minus 2.
Yeah, which I think is a lot nicer.
Yeah, so let's put 3x and x. I'm going to... right. We've got 1 and 2. We need to make minus 1. So we get minus 1 plus 2.
Is it 3x squared? Take away 3, add on 2 is take away 1. Yeah, 0 equals that.
So
That's a bit nicer, isn't it? Sorry about that. It was a bit disgusting what I had a minute ago.
0 equals 3x plus 2, so x is minus 2/3,
Yeah.
and x, in this case, minus 1 is 0, so x is 1. So the points on the graph, so they're going to be coordinates, where the gradient is equal to 6, are going to be...
Yeah. Well, it's like, if we've got our graph, our original cubic.
So we're looking at the original cubic.
Yeah.
So we're gonna have
And
to
there's a
put-
point where the 6 is quite steep, isn't it?
Yeah.
So it's probably like here somewhere, and then also over there. And we found out that this x coordinate is minus 2/3, and that x coordinate is minus 1. Or 1? 1. So, yeah, those are the 2 points. And, yeah, the thing is, you're right. We haven't strictly speaking. I think in an exam, if they wanted coordinates, they would say coordinates.
Okay.
But you're right, what we haven't found is the y coordinate. How would we get the y coordinate?
Well, now we're back to the other part of the problem, aren't we? Because we're talking about a quadrant.
Yeah.
But now we're looking at points on the original graph, and we know where x is. So we're going to need to use the original thing and say, well, y is... I'm just going to use the 1
Yeah.
for an example.
Yeah.
So 2, 1, 3 minus 1 squared plus 2 times 1 minus 1,
Yeah.
which is 2 minus 1 plus 2 minus 1. That whole thing is just 2. So we know that one of
Yeah.
the points is...
So that's this one, yeah?
Yeah.
So this is the point 1, 2.
Yeah.
And this is the point minus 2/3,
Whatever the...
something that we can't be bothered to work
Yeah.
out. Yeah.
Yeah.
Yeah. Yeah. So the big thing was the word gradient,
Yeah.
which means that we knew we had to differentiate and get the gradient function, and then realising that because we know what the gradient is, it's 6, it was 1, but it's 6 now, we could substitute that in here. That's the step where most students don't take that step. They realise they need the gradient, but they don't understand that they can swap dy by dx for 6 when they know what that gradient is. And then you have to solve the equation. Last one?
Right, what are the points on the... at what points on the graph is the tangent to the curved line parallel to the line 3x minus y plus 1? Right, I want to know what the gradient of this line is. So I'm going to put it back into the GCSE formula.
Yeah,
because
brilliant.
That's
Brilliant.
going to be so much easier. So I want y equals something. So I have got y equals 3x plus 1.
Yeah.
So the gradient of that line is 3.
Exactly. And then we know that this means
It means it's the same gradient.
same
parallels.
gradient, yeah. So this whole second bit of this question is just saying we need the graph, the tangent to have the same gradient as the gradient 3.
It's really we've got has gradient 3.
Yeah.
Yeah.
Exactly. So it's
So we're
actually
saying-
it's the same as this question. Where is the gradient 6? Where is the gradient 3? It's just disguised with this little additional bit where they say parallel to, so same gradient as, and then you have to work out that gradient. Yeah. So we need to know where is the gradient of 3?
So we need to know the gradient function, don't we, which is 6x minus 2x plus 2. And we want to know where that is equal to 3.
Yeah.
So we can
That's
just
it.
pop
Yeah,
that
that's
in
the
there.
important thing. dy by dx is 3. The gradient is 3.
So squared 2x plus 2. Is this one going to be particularly nice? 6x squared minus 2x minus 1.
I don't think that's very
No,
nice.
that's not very nice at
No,
all.
sorry about that.
We could use quadratic formula, couldn't we?
It's disgusting. I just hate it. It's disgusting. Can I change your gradient again?
Yes.
Okay. Okay. Right.
But you have to go through and change it all the way back for the question.
Okay.
Mhm.
All right. No, but I want to because I want it to be nice. Okay. I will make. Well, this way we get to do another example. So I will change this line to this line.
Okay.
Okay. So, but we'll still have parallel. So we'll still have same gradient.
Yeah.
But hopefully, I think this gradient's going to be a bit nicer. So I agree with you what you said. We need to make this say y equals, don't we? Is that right?
Yep.
So y equals 3x. No, it's the same. It's the same gradient. It's the same gradient, isn't it? Oh dear. Now what happened when we tried to solve it?
No, we had a gradient. Oh, you did a gradient.
6x squared minus 2x plus 2. Gradient is 3. 3 is 6x squared minus 2x plus 2. So 6x squared minus 2x minus 1
Yeah.
is 0. So formula,
Yeah.
x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So this is 2 plus or minus the square root of 4 plus 24 all over 12. So this is 2, it's a v, 2 over 12 plus or minus a 12th of the square root of 28. 28 divisible by 4?
Yes.
Root 4 root 7 and root 4 is 2, so x is, I don't know why I was making a fuss about this to be honest. Yeah, 2 divided by 12, 1/6 root 7.
So not nice, but solvable.
I know, I don't know why I had a tantrum about using the quadratic formula really.
Just don't like it.
No, I just don't like it. But it's fine, I mean it's a quadratic, we can solve quadratics, it's not a big problem. So there's 2 places where the graph has a steepness of 3 and therefore is parallel to that line. And those are the 2 places. And if we wanted to know what the y coordinate was, we go back to the original, not this line, this is irrelevant now. All this line did was tell us that the gradient was 3, and then once we know the gradient's 3, we can just ignore the whole thing, totally ignore it. Basically, all we needed that for was to get the gradient. So where is the tangent to the curve? Where does it have gradient? Once we've extracted that information, that line's irrelevant. So if we did want to know the y coordinates, we would put these x's back in there, which I'm certainly not going to do, and then we'd find the y coordinate.